Just look at this bunch of transistors, wires, coils, cameras and memories. Using this you can do really awesome things.
But here's the thing, this little board by itself can do all the work. To create amazing things like self-driving cars, voice assistants, or even the list of recommended videos on YouTube, you will have to use neural networks. First you have to know its basic unit, which is the perceptron.
A perceptron uses 3 different values, which are inputs, weights and biases, and they work in a pretty simple way. First, multiply each one of the inputs to its corresponding weight. Then you have to sum them up to finally apply a bias. And here is the interesting part. We need our values somewhere between 0 and 1, and the way we measure that is using a function. In this case we will use the signaling function. So, as you can appreciate, every value will be between 0 and 1. Now we have an output value.
And how does a complete neural network work? Well, first of all you have to know that it is divided into 3 parts, which are the input layer, the hidden layers, and the output layer.
To start making our own network we have to use a simplified form of the perceptron. You have to notice that the value x is just the value for activation. If you remember, we are using the signaling function, which in this case is also our activation function. From the activation function we get our output. And you have to remember that from each perceptron we are getting just one output value. Now, when we are talking about a complete network, it is basically the same story. Just multiply, sum, apply the bias and activate the function. Here you may wonder, why is there more than one output per perceptron? Well, there is not. What you are seeing here is that the output has to be sent to each one of the perceptrons on the next level. When the information moves farther and farther, it is becoming more abstract and also more complex. Here, do you think that this network is ready to work? Well, not really. First, you have to train the machine using backpropagation. It consists in the minimization of the cost function to its minimum value. Basically, it is the difference between the actual output and the desired output. But here we will use this model. This represents all the weights in our network. Now, for practical purposes, let's visualize this W as if it were just one single weight. Imagine it is right here. It is so far from the minimum cost value. What you will do is to use the optimization function. This calculates the gradient descent to move down to the minimum. You have to repeat this process over and over until the minimum is reached.
Thanks for watching this video. See you next time!